Okay, we learned about linear combination and linear dependency or independency. Now it's time to talk about vector space. Vector space is one of the central ideas in linear algebra. And we can define a vector space by introducing a set of axioms. But I don't want to do that. I want to define a vector space intuitively because we don't need the formal definition in order to understand and use the concept of vector space. A vector space is the set of all vectors that can be obtained by linear combination of some linearly independent vectors. I want you to notice the bold words here. The vector space is a set of vectors, here the set of all vectors, that can be obtained by performing linear combination on some vectors, but those vectors need to be linearly independent. Let's take a look at an example. Assume that we have two linearly independent vectors in a two-dimensional plane. So you know that we can perform linear combination on these two vectors and get any vector in this plane. So the set of all possible vectors by combining u and v is the whole plane. And this means that our vector space is the whole two-dimensional plane. So we obtain all vectors in our vector space by combining u and v. We call u and v the basis vectors of our vector space. In fact, these two vectors are building blocks of our vector space. We can build any vector in our set by combining these two vectors. But the question that arises immediately is why these two vectors? Why not two other random vectors? The answer is that we can choose two other independent vectors and then combine them, and again we get the whole plane. We obtain all possible vectors in the plane. So this means that basis vectors are not unique. A vector space can have infinitely many basis vectors, but the set of basis vectors always have the same number of vectors. And we call that number the dimensionality of the vector space. So when we have a two-dimensional vector space, we mean that it's a plane with two dimensions, but we also mean that all basis vectors contains two vectors. The reason is that when we have a two-dimensional vector space, we can't have a basis vector with just one vector, because a single vector spans a line, not a plane. On the other hand, we can't have more than two vectors, because more than two vectors in a two-dimensional plane are not linearly independent. They are linearly dependent. So it doesn't satisfy the definition of vector space. So basis vectors of a two-dimensional vector space always have two vectors.